Have you ever really stopped to think about the sound your finger makes when you swipe across your phone screen? Yeah, probably not, right? But what if I told you that that tiny, almost silent little whisper of friction could actually be used to steal the one thing that secures your entire digital life? Your fingerprint.
Okay, so let's just dive right into this. Picture this very normal scene. You're on a Zoom call for work. Maybe you're chatting with friends on Discord while you're gaming. You're talking, you're listening, and at the same time you're scrolling through an article, you're checking a text, just idly swiping. It's totally second nature.
But here's the thing. Through that open microphone, an attacker on the other end of that call could be listening in.
And they're not interested in what you're saying at all. Nope. They're listening for something much, much more subtle, and honestly, way more valuable. The unique sound of your finger sliding across that glass screen.
Now, this isn't some sci-fi movie plot. This is a brand new kind of digital threat, and it's based on a method called a side-channel attack.
So to really get this, we first need to know what a side channel attack even is. Instead of trying to, smash down the digital front door by guessing a password or breaking encryption, attackers look for these little unintentional clues that a system leaks out. Think of it like a spy trying to crack a safe, not by drilling it open, but by just listening to the tiny clicks of the tumblers. In this case, that sound, that's the leaked clue.
And the opportunities for them to capture the sound are, well, pretty much everywhere. Researchers gave this attack a name, Print Listener, and it can be pulled off during any activity where your mic is on and you might be touching your screen. We're talking work meetings, video calls with your family, even while you're commenting on a live stream.
But okay, how can a simple little swipe sound possibly reveal something as complicated as a fingerprint? The secret, it turns out, isn't in the image of the print, but in its physical structure.
We tend to think of our fingerprints as these flat, 2D images, but on a microscopic level, they are actually three-dimensional landscapes. Your finger pad has this totally unique terrain of tiny little ridges and valleys. Now what's so cool about this slide is how it just visualizes that perfectly. On the left, you've got the standard 2D print we all know, but on the right, that's its 3D map. Now, when you drag this unique landscape across the screen, those little ridges create a very specific amount of friction, and that friction, it generates a sound.
The researchers actually call this roughness noise. It means a finger with a whirl pattern is going to generate a different sound than a finger with a loop pattern. It's this super faint but distinct sonic signature that contains the key information about the type of fingerprint you have.
So now that we know why a fingerprint has its own sound, let's look at how an attacker can turn that faint noise into a forged key to your digital life.
The process is basically a four-step digital heist. First, they record the audio from a call. Second, they use some really sophisticated filters to just strip away everything else, your voice, any background noise, until only that tiny friction sound is left. Third, an AI model that's been trained on all sorts of friction sounds analyzes the signal and predicts the basic pattern of your print. And finally, they use that info to forge a digital master key.
And that last step, that's the most critical part of this whole attack. The key they forge isn't just some random fake fingerprint. It's a highly specialized, targeted weapon.
And really understanding the difference on this slide is so important. A standard masterprint is kind of like a generic skeleton key. It just tries to randomly match common features found in lots of different fingerprints. It has a super low success rate. But a pattern masterprint? Oh, that's a whole different ballgame. If the attacker knows you have a whirl pattern, they generate a master key that is specifically optimized to fool sensors looking for exactly that pattern.
And this chart just brilliantly illustrates why that is so much more effective. Researchers found that in a big database of mixed fingerprint types, only about 8% of them could act as a potential master key. But, and get this, when they looked at a database of only whirl fingerprints, that number shot up to over 17%. By just knowing the pattern, the attacker massively increases their odds of finding a key that'll work.
So this all sounds really clever in a lab, but how well does it actually work? I mean, what's the real-world impact of an attack like Print Listener? Well, the numbers are seriously concerning. Against partial fingerprints, the kind we all use for a quick unlock on our phones, Print Listener can successfully break into an account nearly 28% of the time. And that's within just 5 attempts at the highest security setting.
And even against the more secure, complete fingerprints, the attack still has a success rate of over 9% in 5 tries. For a system that's designed to be totally unique to you, a nearly 1 in 10 chance of being cracked by a remote attacker is a massive, massive vulnerability.
And let's just put that in perspective.
When you compare it to the older, generic Fingerprint attack, Print Listener is up to 2.6 times more effective. This isn't just a small improvement. It's a huge leap in the threat level against the systems we all rely on.
It matters because we use our fingerprints for literally everything: unlocking our phones, approving payments, accessing our sensitive health and financial data. This one little biometric key protects our entire digital lives, and Print Listener has found a way to copy it just by listening.
The good news is there are ways to defend against this. On a personal level, the simplest thing is just awareness. Try to avoid swiping on your screen when you're on a call. But the real solutions have to be technological. App developers can build in noise reduction that's designed to filter out these specific sounds, or they could limit the audio quality just enough to make the data totally useless to an attacker.
You know, Print Listener opens up this fascinating and frankly a little terrifying new way of looking at security. It proves that even the most insignificant, unconscious things we do can leak incredibly sensitive data. It really leaves you wondering, if the sound of your swipe can be stolen, what other secrets are our devices telling the world without us ever even knowing?